everyone, welcome back to my channel Learn with Simran. In this video, we are going to discuss about one of the important topic while handling data. How to handle outliers in dataset. We will talk about what outliers are, why they are so important and different ways to detect outliers using Python. So let's not delay it further and get the learning started. So what exactly are outliers? An outlier is a data point that differs significantly from the rest of the data. Imagine you are looking at a data set of people's heights. And most people are between 5 to 6 feet tall, but there is one person who is 8 feet tall. That person's height is an outlier. Let us see why it is so important to identify outliers. Outliers can have a big impact on data analysis. They can distort averages, skew the results, and lead to incorrect conclusions if not handled properly. For example, in machine learning models, outliers can cause errors or mislead your model's predictions. Sometimes outliers are noise, like errors in data collection, but other times they might be valuable insights, such as detecting fraud. This is why it is critical to detect and handle outliers before moving forward with your analysis. There are a few key methods to identify outliers. You can use statistical methods like z-score or interquartile range, visual methods like box plot, scatter plots, or histograms. Next, let's walk through each of these methods using Python. Here are few of the Python libraries present for outlier detection using Python. The first method is the z-score. The z-score tells us how many standard deviations a point is from the mean. If a point's z-score is greater than 3, it is considered as an outlier. Let us see how to implement this in Python. Step 1. Import required libraries. We will import NumPy and from SciPy import stats. SciPy is an open source Python library used for scientific and technical computing. It builds on top of NumPy and provides a wide range of functionality for tasks commonly encountered in data science and data engineering. Step 2. Calculate z-score for the dataset as follows. Finally, define a threshold. Use Finally, define a threshold. Usually, a z-score greater than 3 is considered as an outlier. This will give you the index positions of the outliers. Next, let us look at interquartile range or IQR. The IQR is the range between the 25th percentile Q1 and the 75th percentile, often referred as Q3. Any data point falling below Q1 minus 1.5 into IQR or above Q3 plus 1.5 into IQR is considered as an outlier. Here's how to implement the IQR method in Python. Step 1. Import libraries, NumPy and Pandas. Step 2. Calculate IQR using the formula, and here's how you can calculate in Python. Step 3. Detect outliers using IQR rule. Lower bound is equals to Q1 minus 1.5 into IQR as I told before, and upper bound is equals to Q3 plus 1.5 into IQR. Outliers for the data below the lower bound or upper bound is considered as an outlier. And this is how you calculate outlier using IQR method. Another way to identify outliers is through box plots. A box plot gives you a visual representation of the data sets, distribution, and highlights outliers as points outside the whiskers. Step 1. Import libraries. Here we will import matplotlib and seaborn. Step 2. Create the box plot using the dataset. Step 3. Interpret the outliers. Points present outside the whiskers are the potential outliers. So this is how, using a visual detection through box plot, you can see the outliers present in your dataset. You can also use a scatter plot to visually identify outliers, especially if you have two variables. Outliers will appear as points far away from the cluster of other points. Let us see how to create a scatter plot. Step 1. Import library matplotlib. Step 2. Create a scatter plot for the dataset present. Step 3. Identify the outliers. Look for the points far away from the main cluster. Any data points which is significantly different from the present clusters are the outliers. This is how you visualize outliers using a scatter plot, especially for two variables. Once you have identified the outliers, what's next? You can handle them in several ways. Remove them if they are errors. Impute values if they are extreme but valid. Transform the data using log, transformation, or scaling. It's always important to understand the reason behind the outliers before deciding how to handle them. Are they noise or do they represent something valuable? Let us discuss the key takeaways from the video. Outliers can impact data analysis significantly. So identifying outliers using statistical and visual methods is crucial. Python libraries like Pandas, NumPy, and scikit-learn provide powerful tools for detection. Handling outliers appropriately depends on the context. Handling outliers can make a huge difference in the quality of your analysis. So be sure to give it the proper attention it deserves. In case if you have liked this video, do like, share and subscribe to my channel Learn with Simran. Thank you so much for watching. Keep learning. Bye bye.